Hello everyone. In this video we're going to talk about unpacking and simply variable unpacking in Python. I think it's a very cool and good feature of Python programming language. We're going to see a lot of examples, so just bear with me. Um let's say that we have a list containing three elements, 10, 20, and 30, and I wanted to assign each element to one variable. Let's say I wanted to assign 10 to some variable, 20 to another variable, and 30 to another variable. I could just simply write down something like this. So A, B, and C equals this list containing three elements. So this is simply unpacking in Python. What you have to understand is that the number of variables that we have on the left hand side is equal to the number of elements we have on the right hand side in the collection. So if we were to run this code, we would see that A equals 10, B equals 20, and C equals to 30. So this works perfectly fine. And it doesn't really matter the collection that you're using is a list or a tuple or any other um, collections that we have in Python. So we have a tuple here. 10 goes to A, 20 goes to B, 30 goes to C. Let's say that, what if we had something like this? What if we have A, B, and C, and 10, 20, and 30, and 40. I'm going to just add another element here. So we have four elements on the right hand side and three variables on the left hand side. Let's see what happens. So this will raise an error, and the error simply tells you that you have more values on the right hand side than the variables on the left hand side. So you have to pay attention. I told you, if you want to use something like this, if you want to use this syntax for unpacking, you have to pay attention that the variables and the values on both left and right hand side of the assignment should be the same. So what could we do here? We could just add another element, right? Add another variable on the left hand side. We could just simply say D, and now it works perfectly fine. But I want to do something different. I want A to be equal to 10, B equal to 20, and whatever is left, I want them to go into C. So I can use a special operator here, a star operator, and let's print the results here and see what happens. So when we run this code, we can see that A equals 10, B equals to 20, and we have the rest of the elements packed into a list and assigned to C. So you have to pay attention. We had a tuple here, but whatever was left was assigned to C as a list. So let's change it a little bit. What if I wanted A to be equal to 10, C equal to 40, and 20 and 30 go to B? So let's test it. Now you can see that A equals to 10, B equals to a list containing 20 and 30, and C equals to 40. Let's change it a little bit. I want the first two elements to go to A, and the last two elements could go to B and C respectively. So now you can see that A equals to a list of two items, B and C equals to 30 and 40 respectively. So let's use unpacking with dictionaries. I'm gonna define a dictionary. I'm just gonna pause the video. So we have a dictionary here containing 3 keys and 3 values. So let's use A, B, and C with this dictionary and see what happens. So when we run this piece of code, we can see that A equals name, B equals to city, and C equals to age. So this simply tells us that when you use unpacking on a dictionary without any methods here, what was assigned to the variables was the keys of the dictionary. So this doesn't really, uh, if I say something like this, they're just this. We're gonna just get the same results. So I could just simply say dictionary values, and it would give me the values of the dictionary, and I'll unpack the values of the dictionary to A, B, and C respectively. So what if we were to use items here, items of the dictionary? So now you get that name and John goes to A, city and year goes to B, and age and 20 goes to C as tuple. But one of the cool features of unpacking is that we can just unpack the elements of the items when we are assigning them to each variable. So now let's say that I wanted to separate and assign each of these elements to different variables. So let's say if this works, A, B, C, D, E, and F equals person dot items. And let's just print this and see if it works. This doesn't really work because this is not the syntax to use something like this. So you can see that it tells you not enough values to unpack. We expected 6, got 3. So what happens here is that if you want to unpack such a thing, you have to do it like this. I'm gonna put parentheses here. And let's run the code again. So now you can see that for the first items, name and John, I just unpacked it into this tuple containing A and B, and A name was assigned to A and John was assigned to B. The next one, B, city and New York, and the next one, E and F, age and 20 was assigned to E and F. So this is pretty cool. You can actually do something like this. So what if I had a list of let's say items, and I had a list like this. Let me add a string here, 2 numbers, and let's just add another list here, right? Let me 100, 200, and 300. Okay, so unpacking goes beyond this simple things, and you can use it for different and more complex scenarios. So what if I wanted each of the elements of this list to be assigned to a variable? So let's just say A, B, C, and D to be assigned to items, and let's just print A, B, and C, and D. So D equals this. So as you can see, name was assigned to A, 20 was assigned to B, and so on. So what if I wanted, to separate each of these items too? What if I wanted to just get different variables to be assigned to these elements? So I could just write down something like, let's say if it works, let's say that I have D, E, and F, and let's put list notation here, and let's just print them again and see if they work. Yes, it perfectly works. And A name was assigned to A, 20 was assigned to B, 30 was assigned to C, 100, 200, and 300 was assigned to D, E, and F respectively. So this is one of the cool features of unpacking, that you can actually unpack the elements inside a collection inside another collection, like a list inside another list, and it is called the nested unpacking. This would help you in different scenarios, like let's say that again we have items, and let's define this time a tuple. The first one is string 1, the second one is string 2, and the third element is another tuple containing 2 numbers. And then we could just say that A, B, and star numbers equals to items. And let's see if it works. So when we run this piece of program, you can see that star operator just forced the interpreter to put this item, this element, into a list and assign it to numbers. So what if I were to do something like this? Numbers is the tuple containing 2 elements, but I want the elements to be separated. So just pause the video and do it yourself and see if it works. Yes, you guessed right. So we could just simply say that num1 and num2 and put them inside a tuple, and I would say num1 and num2, and so we get A equals string 1, B equals string 2, num1 and num2 are equal 10 and 20 respectively. So this would help a lot. Let's say that we have a tuple containing some numbers, let's say some random numbers, 4, 40, 100, 2, and 3. And we were to just find the last element. We wanted the last element, and we could just simply write down something like this: A and B, and now A equals a list containing each element, every element from the first element to 2, and B is gonna be 3. So let's just write it down. Now you can see that A equals a list containing every element from 10 to 2, and B equals to. One of the things is that you can use unpacking inside loops and inside functions, and we're going to talk about them in another video later on. But here, let's say that I wanted to say something like this: for key and val in person dot items. So you might have seen this piece of code before, and you didn't even know that you are using unpacking. So person dot items gives you tuples containing every key and value inside the dictionary, and you are unpacking the tuple into key and value, and you get the results. So you can see that key and value: name and John, city in New York, and age and 20. One of the other use cases of unpacking is just unpacking some elements and ignoring some other elements. So what if we had something like this? We have a tuple here containing another tuple as the first element, and the first element, this tuple shows us the birth date of John. Here we have a name and we have some numbers here. So what if we wanted only the year, of the birthday of John? So what we could have done here is that we could just simply say that this is day, month, and year of John, and then the name, then two numbers, and I could just say something like this: equals person. I could just write down something like this: day, month, year. 3 goes to day, 13 goes to month, 2023 goes to year, and John goes to name, and the other numbers goes to number. Let's print it out, and we can see that here's the result. So what if I didn't need any other variables here? Let's say I didn't need day, month, or numbers. So in such cases, you could just use throwaway variable names, like IGN, for ignored, or underline, So I'm gonna just write down something like this. I'm gonna just put underline here, another underline here, and another underline here. So let me change this. So as you can see, 3 goes to this variable here, 13. Again, this variable is reassigned to 13. Then 2023 goes to year, John goes to name, and the other goes to this variable again. So these are just this is a variable. This works just fine. And now underline could be a name of variable, but we use underline or IGN for ignored or throwaway variable names. We don't really are gonna use these variables throughout our programs. We're just ignoring them. So if we run this program, we can see that year is equal to 2023 and name is John. So feel free to talk about this topic. I think it's one of the cool features of Python, and feel free to ask about any questions that you had, and just share your thoughts. Thank you very much for watching this video, and we'll see you soon.